Alright, today we're talking about section 11-5, which is on the volume of pyramids and cones. Let's just get right to it here. It says the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So this may remind you of when we were looking at the volume of a prism. We would have the volume of a prism, supposed to be an R there, was just the area of the base times the height. So this is just 1/3 of that. So let's look at this picture here. So if I have a prism with the same base, right, so B here was the same, and it came up like so. It came up like so, and then the back came up here. If it had the same height as this pyramid, then the volume of that prism would be 3 times as much as the volume of that pyramid. So the volume of the prism is 3 times more than the pyramid, or you could say the pyramid is 1/3 of the prism. I'm going to show a video in class that will kind of help illustrate that, involving filling up pyramids and prisms with water. So just so you know, that's going to happen at some point. Alright, first example, it says find the volume. We have a square pyramid, and what it illustrates here is that the base excuse me, the base of that pyramid is 40 and the slant height is 25. Now here's a common mistake. So this is just in case you're watching this on mute for some reason. Here's a mistake. A lot of students will say, oh, the volume is just 1/3 times the base is 40 squared, which is good, times 25. But the mistake here is that the 25 is not h, right? This is not h. This is your slant height, which is not your height. Okay? So that's a common mistake, so don't do that, or I'll be sad. And you don't want to make a math teacher sad. It's never fun. So, how do we do this problem? Again, let's first look at the base. The base is a square. It's 40 by 40, which is 1,600 square feet. Right? Should be pretty straightforward. The height now, you should be somewhat familiar with this concept, but I'll readdress it again. You're going to draw your height here. You're going to connect the center to your slant height, creating a right triangle. So if I were to draw that triangle over here, it would look like so. So this is the height. This is 25, because that's the slant height. Now this length at the bottom is half of the entire base. If the entire base is 40, then this should be 20. And hopefully you notice that this is a 3, 4, 5 triangle, because this is 5 times 5, this is 4 times 5, and this should then be 3 times 5, which is 15. So we know that our height is 15. Okay? So that's how you use your slant height there to help you out. Now, to find the volume, we just plug this in. We have 1/3 the area of the base times the height, which is 1/3 of 1,600 times the height is 15. Now, some students don't like to use fractions, so when they multiply this, they get 1,600 over 3, and they get confused. You can use the commutative property here and multiply the 1/3 times a number that is divisible by 3, assuming there is one, which will help. So if I multiply the 1/3 into 15, I get 5, right? So this is 5 times 1,600, which is just 8,000. And don't forget your units, 8,000 what? We have cubic feet. Okay, so we have 8,000 cubic feet. That looks like it says squared, doesn't it? I said cubic and then I wrote squared. So 8,000 cubic feet. Okay? And again, just to reiterate this point, if you had a prism with this same base here, so a base of 20 by 20, you would have done the volume equals BH, which would have been 1,600 times 15, right? Because that's the height, and you would have gotten 24,000, which again is 3 times the amount of our answer here, okay? 3 times the amount of our answer there. Anyway, another type of problem. If the volume of a square pyramid is 1,000 cubic inches and the length of the base is 20 inches, find its height. So, we can just use the formula. If you want to draw the picture, you can, but for these ones, it should be pretty straightforward to use the formula. So, the volume is 1,000, so I'm going to replace the V with 1,000, equals 1/3 times B. Well, we don't know B yet. We can find it, though. If the length of the base is 20, that means the area is 20 squared because it's a square that's 20 by 20, right? So B would be 400. Let me get that out of there. So the base would be 400. And then height. Now again, a lot of students are going to multiply these, get a fraction, and start to panic a little bit. I think the easiest thing to do here, if you don't like fractions, would be just to multiply both sides by 3 right away, because you can cancel the 1/3 and 3. Then you get 3,000 equals 400h. Divide both sides by 400. And you get h equals, if I want to simplify this fraction, divide them both by 100, meaning get rid of those 2 and zeros. Then divide them both by 2, you get 15/2 inches, or 7.5 inches. Okay? And again, there's a lot of work here, so make sure you box your answers, whether you're in my class or not. Just makes your teacher's life a lot easier. Anyway, let's move on. The volume of a cone. It has the exact same initial formula as the volume of a pyramid, and hopefully you've noticed in this chapter, cones and pyramids have been pretty much parallel in their the structure of finding their surface areas and volumes and things of that nature. So, volume of a cone is 1/3 the product of the area of the base and the height of the cone. Now, again, the base of a cone is a circle, right, which has an area of pi r squared, which is where this other formula comes from. It just replaces b with pi r squared. You can memorize one of them, you can memorize both of them. I usually just remember that cones and pyramids are both 1/3 bh because there's already a lot of formulas to know in this chapter, right? So I like to reduce the amount of formulas as much as possible, kind of treat cones and pyramids the same, and then deal with the circle from there. Anyway, so this does have another similarity though. Just like the pyramid was associated with the prism, right? It had 1/3 the volume of the prism. This cone is going to have 1/3 the volume of the cylinder that has the same base and the same height. Alright, so if I filled that blue cylinder up, I could do it, it would hold 3 times the amount of whatever I filled up, rice or liquid or beans or I don't know, whatever you want to fill up, the coins. It would hold 3 times, has 3 times the space as the cone. Or similarly, the cone has 1/3 the volume of that cylinder. Okay, so that's kind of the concept there. Let's look at some problems. So, first of all, we have a cone. It has a diameter is 12 and a height of 12. Okay, so again, to figure this out, we have V equals 1/3 BH. Well, to find the B, we need the volume is 1/3 pi r squared, that's our base, and then times the height. Well, we know, I'm going to move up here, we know the height is 12, right? So I get V equals 1/3 B times 12. The area of the base, we don't use this 12 for the diameter in the area of the base. We need to realize that the radius is 6 if the diameter is 12, because you have to cut it in half first. Then the area of the base is pi times 6 squared, which is 36 pi, right? So we get V equals 1/3 of 36 pi times 12. Now you can just 1/3 times 36 gives you 12. So this is 12 pi times 12, which is, doing a separate color here so it stands out, which is 144 pi, and my units are meters, so cubic meters. Okay, so that's, whoa, I don't know what just happened there. That's the structure of this type of problem. Yeah, not really much to add there. Seems pretty straightforward to me. Let's move on. If the volume of a cylinder is, what did I write cylinder? Is 21 pi. Let's fix that. I don't know why I wrote cylinder. That's silly. So we're not talking about cylinders. The volume of a cone. Apologies there. The volume of a cone is 21 pi cubic feet, and the height is 7 feet. Find the diameter. So, again, V equals 1/3 BH, which is 1/3. B is pi r squared. Okay? So what are we looking for? Let's just make sure we understand this word problem. We're trying to find the diameter. Well, in order to find the diameter, the strategy is going to be to first use this formula to find the radius. Once we can find the radius, just double it to find the diameter, right? So that's the strategy here. So we know the volume is, let's change colors here because I'm bored with this color. Don't like it anymore. We know the volume is 21 pi. So that equals 1/3 pi r squared. Do we know the height? We do. The height is 7. Okay? So now we're just going to solve for r. So I'm first going to divide both sides by pi. Those will cancel. Then I'm going to multiply both, or let's actually divide both sides by 7, I think would be easiest. So we get 3 equals 1/3 r squared. So then, times both sides by 3. That will cancel these, leaving me with, let's go up here, r squared equals 9. Therefore, r equals 3. And if r equals 3 feet, then the diameter would be 6 feet. Now, just as a note of caution, if you are doing this problem on a multiple choice test, or like the CSTs, or SATs, or something, then what you're going to notice is that when you get this answer here, r equals 3, you are going to feel like you are done with the problem, because you solved for the variable. You're going to look over at your multiple choice answers, and you're going to see an option of 3 feet. You're going to get excited, and you're likely going to circle that, without even remembering that what you were looking for was the diameter. So when you're taking a test, if it says find the diameter, and you know, okay, I need to find the radius and then find the diameter, even if you write, like right next to your multiple choice answers, make sure to times by 2, or write diameter again, or something. Make yourself a note that you're going to need to do the extra step, because a lot of students forget. Okay? So, just word of wisdom, I guess. Anyway, that's it for today. Thanks for listening. Hope you learned something. Bye, guys.